Good morning, good afternoon, good evening, good anytime where you're at. It's a pleasure to be here with you today. Sorry, I apologize. Yes, someone was unmuted. So good morning, good afternoon, evening, wherever you are. It's a pleasure to be here with you today for the first event of the year, 2024, our webinar series organized by Big Data Regional Hub in Brazil. This webinar is a part of webinars. We have three webinars monthly that will take place in March, April, and May. And in the end, Marcelo, you're going to advertise the next ones. So I won't take much of your time. Just would like to welcome, to say it's a joy to be here. This webinar is being organized together with NIC-PR, our forever partner. The regional hub is turning 3 years this year, and NIC-PR has been with us since the beginning. It's a pleasure to partner with them. We hope you enjoy. And Marcelo, up to you now. Good afternoon, everyone. Welcome to the presentation of this first experience in the series of webinars talking about new developments organized by the regional Big Data Regional Hub in Brazil, together with NIC-PR. And here we are going to address unconventional database to try and produce official public statistics. The first webinar is going to talk about weighing a non-probabilistic sample to understand internet quality indicators at Brazilian schools. Our speaker, Tiago Meirelles, is a doctor and master of political sciences from Unesp, Brazil, data scientist, from the information technology school. And he's going to talk about probability. It is the topic of his presentation today. The presentation is scheduled to take approximately 30 minutes. After that, we are going to have a Q&A session. Tiago is going to answer whatever questions you have. And after that, after the presentation, I'm going to announce the next two webinars within the set of topic, which is the use of alternative data for the use of official statistics. Tiago? Well, good afternoon, everyone. I'm going to share my screen. Can you all see my screen?
Yes.
Yes?
Yes, we can see it.
Conseguimos.
O Marcelo é dos autores do.
So Marcelo is one of the authors of this paper. We both work at CETIC.br, which is the Regional Center for Studies and Development of Information Society, a center connected to the Brazilian Committee of Internet and its executive arm, which is NIC.br. We're also a UNESCO center. The other author that unfortunately was not able to be here was Pedro Silva from ENSI, IBGE, Brazil. The work has been developed for almost a year now. And the idea is to deal with a database working on quality measurements. So this is what I'm going to talk about. At NIC.br, we have a research center, some different programs, and SEPTU.br has an internet quality sector, which is CIMET. And CIMET has a device that can be a firmware or a software that is installed at a computer to collect information on the quality of internet automatically. So every given time, with the router or computers connected, it collects data. And it tests speed for download, upload, jitter, and ping. These measurements are going to made available only for schools that voluntarily installed CIMET devices, that is, those that already have the devices in place. So we have a self-selected sample, so to speak. The objective here basically is to estimate the quality of internet for a set of Brazilian schools. The available sample is not a probabilistic or probability sample of schools. You have to weigh it for it to become representative. And the target population was defined at all city or state-owned schools that have a computer and internet access. So what we expect is that for you to have, CIMET, you either have to have a router or a computer. And to estimate the assembly measures for this target population, you have to have weights for the non-probability sample. Data sources are basically internet quality measurements that were collected and provided by CIMET. The original database is from April 5th last year, when the devices were installed in almost 50,000 schools. This target population, and basically what we have in terms of population frame, comes from the school census that contains information on all schools in basic education and is provided by INEP. INEP has the survey every year, and that's the data that we used. And the census database comprised almost 225,000 schools in 22, of which almost 104,000 were city and state-owned public schools with computer and internet access. So here we have a more clear picture of what we are talking about. On this table, you have the breakdown of schools based on type of administration, if it's a federal, state, or municipal schools, or if it is private, and whether they have a CIMET device or not. Remember, this is the base of April last year. So we don't have any federal public schools. Private schools are very rare, and therefore we geared towards analyze state and municipal schools only. The challenges for this effort is that we are dealing with big data. Given the number of records, you're talking about almost 225,000 schools, and also the number of variables of the schools, 190 category variables and 113 numerical variables. The use of traditional methods for variable selection to estimate pseudo weights didn't work very well, because all variables in the end of the day would be significant at some point in time. So we used what we called a brute force to try and accomplish a model that would be useful for us to be able to compute those weights, even if too intensive. Our methodology, the methods used to assess pseudo-weighted estimates, followed the estimates of our target population, again, regarding information from the school census. So you get the total number and try to estimate what level of representativeness they would have considering the target population. And then you follow the absolute deviations of the category variables, of numerical variables, and the relative deviations as well. So these are four of the calculations made. And also we had the number of categorical variables that were not within the confidence interval of 95% for the target values. In categorical variables, for instance, if one category of this variable was outside the target, it is as if it hadn't reached the target, and it is the same for numerical variables. If they were out, they would be included here. So the more variables here, the more distant we would be from the target population. Our main strategy was a combination of random forest with logistic models, and we had it in two steps. First, we used random forest for it to give us a suggestion in terms of order of importance of variables to predict CIMET devices' existence. But we did not collect this result to generate the estimate for pseudo weight. We use logistic regression models, including variables selected according to the importance attributed by the random forest model. So in the end of the day, we have an easy, simple logistic model. Y, the school has or not CIMET, X, the categorical variables, and the other, the numerical variables. And for it to be applied, we created a function to calculate the absolute deviation, the relative deviation, and the number of variables outside the confidence interval, both for numerical categorical variables for each model. Again, more than 600 models that were tested, in which we would add 5 variables at each new iteration. So we would start with the model with 5 categorical and 5 numerical. Then we would add another 5, then 10, 5 numerical, 5 categorical, until we got to the 190 variables. And for us to analyze the pseudo weight, we had a more parsimonious model selection, a model with better values of the goodness of fit statistics selected for us not to use all the variables. Otherwise, it would be too half of a model that perhaps would not be the same. So the idea was to ponder, to weigh that as well. Well, as alternative strategies, first, we created an anchor for a good result. So basically a simple random sample that would be used as reference. And that sample had to have the same size as the CIMET school sample. For comparison to our main strategy, we used 2 techniques that are very much used for big data, random forest and Lasso. For both, we used a training set of 30,000 observations to be able to predict the propensity score for target population from all variables. In the end of the day, they both select variables, but at Lasso, we did not have the cross-validation or hyperparameters because it was more of an experimental thinking of the original results to see if it made sense. And here we have the summary of statistics for the applied methods. So you have the deviations, absolute, relative of categorical variables, absolute and relative for numerical variables, and the number of variables out of target.
So when we're thinking of a random sample, here we have some deviations. There's some variations. For deviation for these variables, but more importantly, there's no categorical variables that are out, and there are two numerical ones here. So this would be based on the high number of variables, we can understand that there was a good performance. And that's our reference to compare to other models. When we look at random forest, we see that these deviations exploded. The number of variables goes beyond 65 or even 60%. And with Lasso, it increases even more. Almost 90% of the numerical variables are out, and 165 out of the target. With the combination of random forest with logistic regression, where we use 145, 145 categorical, we have a performance that is not the best. It's not like a random sample, but we reduce very much the bias that this database had. So we have 5 of the numerical variables with the confidence interval out of, and 55 of the category. But if we compare with the other strategies, it's an important reduction. Here we have 2 charts to show how we selected the number of variables. It's exactly the middle, 145 variables and 200. And we see those that are out of the confidence interval with less variables are out, even numerical and categorical. And from here, the variation decreases. So there is a gain by including more variables, but it's not as major as important up to this point. And when we look sum of relative deviations, it's practically the same as the model with all the variables. For the numerical variables, it's basically the same. And for the categories, it's a little better, but not very much so. So we are able to generate a model with less variables, less than the census, and with results that are very similar. Here are some of the tests that we've done recently, and we received a more updated database for those schools that do have the device. So we have the basic model in the first table, from the first table, the inclusion, the same model, but for 65,000 cases, which are on the new database, and a third model, also using the same variables, 145, but with 69,000 cases. So we have 65,000 that were in the second and included those that were in the first database, and we do the calibration. The model does not work in the same way. So if we follow the same 145 variables of the rainforest that we used in random forest, so these results are worse. So this made us suspect that every time we update, we would have to redo the process of the random forest with logistic regression, see what variables, and see how many variables. We are following the same ones from April 2023. We have to redo the whole process to see what variables are more important every time we get new data. How many variables we should include based on the function to calculate the measurements. And the last table where we compare the reference model of 45 based on the first random forest with 45,000 observations. And here, process redone with the RF with the database of November 23, 165 variables, numerical still 5, but we have 20 more categorical. And at the end, we have a fall in some of the measurements. There was an improvement, but simultaneously, if we think that there are almost 20,000 observations more in more than 100,000 schools, and we have 55,000, we still have major bias, even after the adjustment. It's falling, it's less, but we suspect that the group of schools or a cluster that has some problem, and we're thinking about it. Some of the schools we're not reaching that do not comply to the measurement, because we see that with deviations there is an improvement, reasonable improvement, but the number of variables outside the target improved, at least at the categorical, where we had a major problem. So thinking about all the work, even with a non-probability sample, with a major part of the target population, we do have to correct the bias, because unweighted estimates would have considerable bias. So when we think about big data, this is a concern, and it's very important, because if we have a population as a reference for these data and to do the weighting, but we have to understand that even if we don't, what part of the population are we representing? Our proposal that we brought for weighting, it's a midterm. The number of variables of the model and the bias that still continues for some of these variables. One thing that drew our attention was that combining methods brought forth better results than those that are normally used for treating and modeling big data. The inclusion of these new entry records and using the same reference model from 46 to almost 70,000 increased statistics of goodness of fit. That brings as a consequence that when we have many observations as we have, we would have to redo the process, re-identify what are the most important variables from random forest, and do the goodness of fit to have a reference in terms of calculating pseudo weights. And it's important to say that installation of the devices are ongoing, and every quarter databases are updated.
Vai ser refeito. Porque, no fim, aqui a gente está pensando em gerar esses dados para políticas públicas. Na verdade, tem
the whole process is redone, and we have a partnership with the Ministry of Education to try to understand within the states, dividing no matter what kind of administration, if it's public or municipal, but we have less public, we have less private, and less federal ones, but we still can use. And we have to think about the urban and rural classification, thinking of public policy. So the idea is to generate indicators that can be used and that be representative. Part of them are going to be disseminated with a lot of information, but the idea is we want the data to be trustworthy, to have an impact for public policies. I think at the end, I think this is it. If you want to, we can share this presentation, and thank you. I'm open to questions. Thank you, Tiago. The participants that want to ask questions, they can raise their hands in the chat, and we'll read to Tiago. I work with you, so I'll ask this first question. What was more surprising? But I never... The difficulties. Did you expect these results? Actually, in terms of results, I wasn't expecting anything. It was to experiment and try to find a solution that could be more trustworthy, that would be applicable to generate useful indicators. But what the major challenge is computational capacity, because we have 760 models, if I'm not mistaken, and to identify which one would better adjust as the main strategy. The random forest is very intensive in terms of computer work. Lasso, little less in terms of validation, but it's more to try. The challenge is to think of alternative strategies when more traditional techniques don't work, like the combination of two different strategies that would not speak to each other, and random forests for a process of selecting variables. If you were to use a stepwise, in a logistic model, all variables would remain. It would be all significant. So it's another challenge that comes into the process, how to find a solution and try to be creative. There's not a single strategy that's ready for all the challenges that we face and that we will continue facing with big data. Guilherme is asking if by choosing the technique, if we began others, we began with logistic regression, stepwise, to select the most important variables in the model, and all of them got in. And that would be a more traditional method to calculate pseudo weights. And then we went towards these other strategies to think how to select a variable or apply models that would generate importance and weight for each one of the variables that were part of the model. The random forest generates in the decision tree and calculates at the end. There's a calculation for importance, the weight that each variable has for the final model, and in the lasso, some gain weight 0, so they are out of the model. But it works also. So the idea is to try to combine methods that would generate weight for these variables in a more traditional way, That was the way of doing it. So random forest was used for selecting variables and use a more traditional method for weighting.
Giovanni, você, diretor.
Muito obrigado pela apresentação, Thiago. É um grande trabalho.
So it's a very nice work. I have some questions.
Por que tanto se diferenciaram os
Why so many different results using pseudo weights or not using pseudo weights?
se usamos alguma medida
If
de
we used a measurement,
precisão nas estimativas,
an accurate
o erro
measurement
quadrático, o erro padrão, com o uso do
with
pseudocode,
standard deviation,
e se utilizamos algum método de
and
calibração
if we use some calibration method after
para ajustar os
estimate the
totais
pseudo
e
weight
os totais conhecidos de outras
and the totals.
É, é que, na verdade, a gente não
Actually,
pensou na estimação dos
we didn't think of
indicadores,
the
porque a gente
estimates
sabia que
of
era
indicators at the beginning because we know there was a bias
resultado sem e com pseudopeso. Então,
resultados
with and without pseudo weights.
sim, os resultados
And it
da
depends
rede da
on the
UERJ,
quality of
a
internet.
gente não olhou para isso.
We did not
E,
look into this.
no fim, a gente adotou
At the end, we adopted
resultado
a
muito
simple
bom
random sample,
naquelas escolas com
which would
melhor
result in an
mas
ideal
a gente não tinha.
world where we have those schools as measurements. But it was for, we did not have that, but we wanted to understand where we were standing in a simple random sample, in the same universe, in the same target population, and with the same size. At the end, that was the only strategy that we had. We did not calculate the indicators. The indicators themselves are the quality of indicators. The idea of this work is that if we simply used this voluntary sample as a representative sample, it would not be a major bias of the statistic that we know of the census of this study. So certainly they would not be a good measurement of the quality at the schools. So that's why we use the weights to complete this bias, to complete the analysis of the bias. And after we use the pseudo weights for this model that eliminates part of the bias, we estimate the pseudo weights for the marginals that we have, that we want to show the quality measure. So it's a cross between the Brazilian states, the type of administration, state or municipal, and if the school, it was an urban or rural area. These three characteristics, there are totals, and we use to calibrate the pseudo weights, combining random forest and regression. And we have schools in all extracts, so that made it easier.
Mais alguma pergunta?
Any other question? Well, so since there are no further questions on our chat box, I think no one asked for a question. I'd like to thank you all. We apologize for the delay in starting the session. Next time we have 2 other webinars. And it's very important for us to talk about what is to come.
E deles vai ser agora no dia
One of them is going to be on April the 19th, if I'm not mistaken, also a Friday, also at 1 p.m. Brazilian time. And it's going to talk about the correction of bias for COVID estimates in Brazil. And then on May 17th, we have another webinar talking about sampling and inference on weights for virtual environments. I hope you have enjoyed this webinar and that you join us on the next two ones, talking about non-traditional basis for statistic, official statistics in Brazil. These are alternate bases that we have to be careful to use, but that can be very good. So thank you very much and see you next time. Thank you. Bye-bye.